Hey guys, Mrs. O'Donnell here. We're continuing with graphing quadratics, and we're going to talk about the three main forms of quadratics. Our goal for today is to analyze and develop understanding of quadratic functions in standard factored and vertex forms. Continue working through, chipping away at this week's assignment. If you have questions, please come see me. Pop into my office hours or shoot me an email. I'm happy to help. All right, so we talked about a lot of different features of quadratics. So let's do this little warm up. You can take a minute, you can pause the video, try this on your own, see if you can get it right. All right, so if you're coming back from from trying it out, hopefully you know which, or you feel pretty confident in which answer option we've got going on here. So let's see here. We know it's got a negative, but hey, the leading coefficient, right? Our parabola is opening down, so that leading coefficient has to be negative, but that doesn't really help us eliminate any answer options because they all start with negative 16t squared. But then you might notice, well, the next thing we want to look at is this minus sort of trailing number, right? So we've got plus zeros here. And these actually still tell us just like in our linear functions, the b tells us the y-intercept. This like last number here actually tells us our y-intercept. So that helps us to eliminate the b and the d value. They're not crossing our y-axis at negative 256. So then that leaves us with, okay, I've got this negative 16t squared plus 64t and negative 16t squared minus 64t. And hopefully you recognize that you could actually factor these, right? You can pull out a GCF of negative 16t, and let's see here, you'd be left with t minus 4. Or if you pulled out a negative 16, let's see here. Oh, we'd have to pull out a positive 16t for the second one. 16t, and you're left with t plus 4 for the second one. And you can use this and what we know about the zero product property, right? We know that this first t is going to give us this root of 0. But then we can use the second factor to figure out our other root, right? So I don't like how I put those arrows. I'm going to put those arrows pointing to the t value because that's the value we would be plugging in to create that 0, right? So what number goes in for t here that makes this go to 0? That would be a positive 4. What number goes into this t that would make that factor go to 0? That would be a negative 4. But we see right here our other root is at a positive 4. So we know it has to be, our answer option here has to be A. Okay. You could have also grabbed a calculator or hopped on to Desmos.com and used their graphing calculator to just graph it and compare the graphs. And of course, if you ever don't have access to graphing technology, you can always make that t table, right? You've got a t, you've got your input and your output, right? Pick a couple of values, so 0, 1, 2, 3, plug and chug, right? Plug into your t value to see, follow PEMDAS, those order of operations, okay? To see what your output values are, okay? Follow those order of operations to see what your output values are and which ones match up, right? Did you get an output of, about 48 when you plugged 1 in? Did you get an output of 64 when you plugged 2 in? Okay, and so on and so forth. All right, so we have 3 different forms that we use with quadratics. We have standard form, which is ax squared plus bx plus c. Notice that its standard form of a polynomial, the highest exponent is a 2, and your exponents are all written in descending order. Your A, B, and C just represent numbers. Okay, then we have vertex form, which is A times x minus h squared plus k, where A, H, and K all just represent numbers. Your X is that variable, but you've got sort of this interesting grouping with your parentheses where you have some stuff inside parentheses squared, but you also have some stuff outside of the parentheses as well. And last, you have factored form, which is what we've been talking about a ton lately. We've been doing all that factoring. And here again, you've got an A value. So notice we had an A value in every single one of our forms. You've got that A value, which is just a number. And then you've got this x minus x1, which is your first factor, and x minus x2, which is your second factor there. Okay, and there's some key characteristics that each form is going to tell you. Okay, so standard form, that A value tells you if your parabola is going to open up. If you have a positive A, your parabola is going to open up. If you have a negative A, your parabola is going to open down. And then you could get, we talked yesterday, we got more specific. If you have an A value that is greater than 1, you end up with that stretched parabola, right? When A is greater than 1, and when A is between 0 and 1, you have that compressed parabola, right? Okay, and so the A value tells you a lot, and you've got that in standard form. It tells you if your parabola opens up or down, if it's stretched or compressed. And you also see very easily the y-intercept from standard form. Okay, so you see that y-intercept. From vertex form, let's go ahead and change color. From vertex form, you're going to see the vertex. Your vertex is going to be at the HK, the coordinates HK. Now the H is that number after the minus sign, and the K is that number after the plus sign. So that's going to be your vertex of your function. And again, you still have that A value telling you is your parabola opened up or down? Is it stretched or compressed? Okay. And then factored form. In factored form, let's see here. In factored form, we've got, again, we've got that A value, right? So that A value tells you, is your parabola open up or down? Is it stretched or compressed? And then you've got your factors, which tell you your roots or your x-intercepts. We call them roots. Sometimes we call them zeros. Okay. Sometimes we just call them factors, right? So all of that. Okay, your x-intercept. So your factored form tells you that key important information. All right, so knowing that key information that we just went over on the previous page, go ahead and pause the video, take a minute, see if you can match the quadratic functions to their graphs, and use, think about the kind of strategy that you're going to use. All right, so welcome back if you paused and you've now unpaused the video. So let's check it out. So if we start with our standard form here, remember we said the easiest thing to see, that A value tells us is it our parabola opening up or down. But then we've also got this C value here, and that's telling us the that C value is telling us the y-intercept. So I want to look and see which graph is crossing the axis. I don't even see positive 4 on graph C. So I see obviously it has to be answer choice B. My graph is crossing my y-axis right there at 4 for graph B. Then let's see here, we've got vertex form. So vertex form is telling us the vertex of our graph. So vertex form, I should have a graph with a vertex at 3, 4. So let's see here, if I go over to 3, up to 4, did I land at my vertex? I sure did. That's going to be A. So vertex form's at A. And factored form, hopefully it's going to show me factors at -3, -4, -3, -4. Bada boom, right there. And we're all set. Don't forget to complete the Google form to get your participation and attendance credit for today. And come to office hours if you have any questions whatsoever. Thanks so much, and I hope you guys have a great rest of your week.